teacher.
Yeah. Okay. May we begin the lesson today? Okay. Uh, I'm sorry that I don't turn on my camera because my camera has a problem. So apologize that I don't use the camera. Okay. Okay. Let me share the screen first. Okay. Today's lesson is about hashing. Uh, as we learned a week ago, we learned about the ADTs the abstract data type. In the abstract data type, we could make user-defined types that there is have some operation on it, and then we could do many data structure that we want using the concept of abstraction. Okay. And then we learn about many entities, for example, the list entities, and then the linked list, and the queue, the stack, tree, and then grabs, and then hashing. Uh, Usually, when we learn about hashing, we must learn other data structure, for example, pointers and something like that. But as my uh, uh, as in this course, I think we move forward to hashing. Okay. Maybe I will not give you programming lesson in here because we will learn about what the technique that we use for hashing. Okay. Uh, so what is the outline for today meeting? The first is what is hashing, and then we will learn about what is the hash function, and then what is the hash table and how we construct the hash function to the hash table. Okay. And then maybe when we are talking about the hashing, some of data collision will be happening, uh, and then we will try to using some methods to do the resolution of the collision. Okay, the data collision. There are two types of data collision. The first type is called open addressing. There is some subtype about open addressing, for example, linear probing, quadratic probing, double hashing, and so on. Okay, and then the second type is a separate chaining. Maybe we will learn it in a moment. Okay, and then we have to determine the key to the hashing. Okay, maybe you heard about hashing. For example, in the cryptographic, when we want to encrypt some data, we use hashing. Uh, Hashing method to encrypt our data. And then when we want to decrypt our data, we are using the hash function to do that, something like that. But in this course, we don't talk about the cryptographic hashing, but it is the hashing that will be used in the hash table data structure. Okay. So it is not about the cryptographic, but it is about the data structure. Okay. Okay. Maybe I will give you one example. For example, this one. Uh, in a sequential search in array, for example, you use an array and you populate some data in the array. You have when you want to find some information in the array, we usually use a sequential search algorithm. There is so many algorithm for searching data in an array, but the most frequently used to searching an element in the array. It's called a sequential search. Okay, how the sequential search working? It's something like this. For example, we have a data entry like this. Okay, we have, for example, we have 6 data that we want to insert to the array. Okay, maybe the data is not ordered. Maybe the data will be ordered. Okay, so for example, when we want to find element with the key 11, this is the key, and then this is the information that hold with the key. Okay, when we want to find an element with the key 11, for example, what we should do. Okay, for example, we have an order array, something like this. So the value of the key will be ordered, something like this. You can see in here in the table, the data is not ordered. Okay, the data is not ordered, but maybe with some algorithm we could order the data when the data is inserted to the array. That's one example. Okay, so maybe we could do something like that to our array, and then the data will be ordered like this. How about when we want to find element 11 to the array? What we could do is, first we need uh, retrieve the first index of the array. For example, this one, 10. Okay, and then we compare the key on the array with the element that we want to find. Okay, 11 is not equal to 10, so that we move to the second index of the array. Okay, and we were here, and then we compare this key to the element that we want to see. Okay, 11 is equal to 11, so we know that the information is held in this array. Okay, then what we could do is, sorry, we retrieve this data, and then we could get the information that hold this data. Okay, and how many data processing that we use for this operation is 2 times. We call this hops. Okay, there's 2 hops. The first hop is index 0, and the second hop is index 1, and then we could get the array. Okay, the data in the array. So we could calculate that the hops is only 2. Okay, 2 hops. It is the when the case is we have an order array. Okay, but in real world it is very uncommon. You know, for example, when user inserted the key 10, there is no guaranteed that the user will insert the value of 11, the key of 11. It's we could never guarantee that. Okay, so we need some operation that you use to sort the array. So we have the order array, but sometimes we don't do that. So maybe we will use the unordered array, something like this. So the user inserted the key 10, and then key 44, 55, 33, 22, and so on. So the data representation in array may be something like this. Okay, 10, 44, 55, 33, 22, and 11 is not ordered. Okay, so the same problem. We want to find an element with the key 11. Okay, so what we will do first is we check the first element of the array. It's not equal to 11, and then the second, it's not equal to 11. 55 is not equal, 33 is not equal, and 22 is not equal, and then 11, it is equal. Okay, So the key in the index 5 is equal to the key that we want to find. Okay, so with that we could retrieve the information in the array, something like this. So sorry, like this. So we could retrieve the array information on the array, something like this. And then how many hop that we use is 1, 2, 3, 4, 5, 6. So we to find the key of 11, okay, we need 6 hops to do that. Okay. Maybe when you use a data structure, something like a struct in C++, you could do that. Okay. Maybe you familiar with that, or maybe not. I think it is the data representation of the in the array. Okay. Now imagine that you have um, million rows of data in the array. For example, you insert all the data about the document in a library, for example. It's maybe thousands of data, and you cannot know that what the order of the data or something like that. It is very a little hops, maybe only 6, because we only have 6 data in here. Okay. How about we have a thousand, a million of data? How many hops that we have to do to access the data? That's called inefficiency. So sometimes when we use an array with a sequential search, it is not efficient. Sometimes something like this. But in array we use multiple algorithm to do the searching. It's not only sequential searching. For example, we could use a more efficient algorithm. For example, is binary search. We divide the problem into two binary into two, and then we divide again into two, and then the data will be retrieved with the other algorithm. Okay, but in sequential array, it is not possible. Something like that. Imagine that you have 1,000 of data, and your data that you want to search is in the end of the data. You have to hops 1,000 times uh, to just to retrieve the data. Okay, that's not efficient. That's why we have to construct some algorithm or some data structure that call hashing. That the best case scenario in the hashing, we could only using one hop to retrieve all the data that you want to search in the array. Okay. That's called the hashing. We will learn about that. Okay, do you have any question for this lesson, for this slide? If you don't understand about something, or maybe when I'm not clear, or I'm too fast or something like that, just call me, okay? Just tell me. Okay, this is the hashing. The hashing is actually an idea that we distribute the data or the element of the element in uniformly across an array. Okay, for example, like this, we have the data entry like this. Okay, it's the same data that we discussed before. uh, we we need a hash function, something that called the hash function. What the hash function do? The hash function is the operation that they do in the hash function is to convert a large key into a smaller key. For example, this. Okay, we have a hash function. The function is very usually very simple. For example, like this. the hash of the parameter key k is equal to k modulus 10. Okay, we use the arithmetical function modulus. Usually we use this function to do that, and then all the key that we have here, okay, all the key that we have here, sorry, all the key that we have here, every time the data will be inserted or searched to the hash search will be through the hash function, something like this. Okay, the hash function is here. So what the operation do is we create an array that's called a hash table. Okay, it is an array that's called hash table, and then the hash table has an hash index. The index is very simple. It's start from 0, 1, 2, 3, 4, and 5, and so on. Okay, it is very simple. It's the same like the index in the array. And then through the hash table, through the hash function, we convert the key number from the data entries into the smaller key. That's called a hash index. Okay, it's called a hash index. So the key for example 44 will be through the hash function, and then it will result an index, and then the index and the data itself will be mapped into the hash table, something like this. So maybe we have some what I call it definition here. The first is the hash function. The hash function is the function to convert a large key into a smaller key that called the hash index. Okay, and then the data will be stored in the hash table that has a hash index. Okay, something like that. Maybe it is more uh, uh, the easier example that I will to discuss with you. Okay, the hash function maybe the for example the division method. The division method is using this formula. HK is equal to k mod the t size. The t size is the how many table that we will use. For example, this we have 0, 1, 2 until 9. So we have 10 hash table. Okay, 10 table size. The table size is 10. Okay, and then with this formula, we create the function something like this. HK is equal to k mod 10. Okay, because the 10 is the number of table that the number of row in the table. Okay, something like that. And then this is the key that we want to convert into the index. Okay, and then the first key is 10, and then we calculate using the hash function. This hash function, h of the parameter of 10 is equal to 10 mod 10. So this is equal to 0. So we have the index 0 in with this method. Okay, index 0. And then we will map the key 10 into the index 0. So something like this. Okay, we map the key 10 into the hash index 0 because we use this hash function. Okay, how about 44? When we use 44, it's 44 is equal to 44 mod 10, it's equal to 4. And then we will place the 44 key into the hash index 4. Okay, something like this. Okay, how about 55? At 55, if 55 modulus 10, it is equal to 5. And we will place the 55 in the index 5. And then 33, we use the same function, something like this. So the 33 mod 10 is 3. So we place the key 33 to index 3. Okay, and then 32, and then 11, something like this. Okay, so maybe maybe you saw that our table is ordered here, but it's not necessary. Okay, it's just about the calculation, because the calculation uh, it is just happening that this is ordered, but that's not an intention to order this data. Okay, something like this. So how about we will want to access 11, the same that the problem that we had before. We want to try to find 11. Okay, how many hop that we want to do? Okay, so using the hash function, this hash function, okay, hk is equal to k mod 10. We calculate the hash index using this hash function. Okay, so I'm sorry, maybe my writing is not good because I'm using a mouse. H11 is equal to 1. Okay, it's the same, like same with this. Okay, and then we knew that the index is 1. Okay, and then we just find in the hash table something like this. For example, the variable hash table, and we could find with index 1, something like this. Okay, it's very simple. In C++, maybe we could use something like this to accessing an array based on an index. Okay, so we could we could only we can only calculate this one based on the parameter of 11, and then we knew that the index is 1, and then we access it with something like this. We knew that it is here. Okay, so we could retrieve the information that hold in the key. How many hop that you think that we do to this operation? Could you give me some answer about it?
It is 2 hops.
Okay. I'm sorry. I don't know what happening here. Okay. Yes. In the computer, it is very fast. Okay. That's when we're calculating something like this, it is usually only using 1 hops. Okay. For 1, because we only access this one. Okay, based on this index. So we only use 1 hop to get this data. Okay, because the processor or the CPU or the computer is very fast, and then when we use the mathematical calculation like this, it is very fast. That's in theory. Okay, it is only 1 hop. Okay, a hop is how the calculation is made, or how the one element uh, uh, how can I describe it? uh, for example, in an array like this. Okay, sorry. The first thing we do is it's called the 1 hop. Okay, 1 hop, and then when we move to the next element, it's called the 2nd hop, and then the 3rd element 3 hops, something like that. But when you see in this example, for example, is how many hop that we could get to the array 11? It's only 1. Okay, we need only 1 hop, because we don't go to 0. We don't go to 0, but it is directly to 1. Okay, because we use this function. Okay, in C++. For example, the next example, when we need to find sorry, Maybe we need to find okay, 55, for example, it's 55. Okay, the index of 55 is 5. So we could get the hash table in index of 5, something like that. Okay, hash table of index of 5. And because of the operation in C++ is very, when we have an index in an array, we don't need to hop from one. But because we do something like this, it's directly into here. Okay, that's one hop. Okay, this two is one hop. Okay, do you get it? Do you understand about it?
Yes, sure.
So what we do here is only one hop. Compared to we search the key 11 in the array using the sequential search, maybe we need to calculate all the data or traverse all the element in the array, so we could get the element that we want to get. Okay, but using the hash function is very efficient because we only use one hop to do that. Okay, it's the best case scenario. Okay. Okay, do you have a question about this?
Yes, teacher.
Yes.
The key is much bigger than T size, right, teacher?
The key, no, it's not. It's not. The key is anything that you want as a key. For example, maybe a string can become a key. All you have to need of the key is how to convert the key into an integer. Okay.
Thank teacher.
So some maybe we have a hash table that the table size of okay. I'm sorry. Okay. What's wrong? Do you still seeing my screen?
Yeah, sure. I can see your screen.
Okay. Okay.
Teacher,
As I said before, the key is doesn't need to be an integer. Okay. I will discuss it later about it. Maybe the key is a string. Maybe the key is a number, a large number, or a simple number, something like that. It doesn't necessarily a smaller number that has table. Okay. Okay. Do you have any question?
Teacher. Teacher, I would like to ask about, like, for example, like if the key is 45. After we move with 10, it also 4. So how can we tell the difference between like 44 and 45?
Okay, that's a good question because that's what the problem that we had. Something like this. Okay. For example, this example. Okay. We have the key 10, 44, 55, 33, 22, and 11. Okay. And then our hash index is something like this. The table size is 10. So the hash index begin from 1, 2 until 9. Okay. And then all the hash index in from 1 to 5, from 0 to 5 is populated with this data. Okay. Something like that. And then how about we inserted a new data, for example, 20, something like this. Okay. When we calculate the using this hash function, the data or the index will be resulted in 0. Okay. So where we place the 20 in the hash index, that's the problem, right? Something like that. Something like that that you asked, right?
Yeah, teacher.
Yes. Yes, this called hash collision. Okay. it is not possible that you give it this the 20 into the hash index 0, because the hash index 0 is already has a key that is 10. Okay, so it is not possible to, maybe it's possible to overwrite the data, but the key of 10 will be lost, something like this. That's called the hash collision. Okay, it is something that the problem of the hash function and the hash table, and the hashing must be uh, overcome that problem. Okay, how can we resolve this? There is some many methods that we could use for collision resolution. For example, there are two main resolution. The first is open addressing, and then the second is separate chaining, and we will discuss this now. Okay. In open addressing, we have three methods that we could use. It's not limited to three, but in this lesson, we will see what is different about these three open addressing method. Okay, there is more than three method that you could see in maybe in the books or in the internet. Okay, the first method is called linear probing. Okay, the algorithm is something like this. For example, we have the table size of 7, something like this: 1, 2, 3, 4, 5, 6, 7. And then the key is still empty because we don't insert something to the hash table for now. And then, for example, we have a hash function like this. HK is equal to k mod t size. It's the same that with the hash function that we used before. So when we insert 50, what we with this hash function, it will result 1. Okay, 50 mod 7 is 1. Okay, and then because the index is 1, we populate the key 50 into index 1. Okay, and then how about 700? About 700, mod by 7 is 0, and then we populate in the hash index 0. How about 76, for example? 76 for 76 mod 7 is equal to 6, and then we place it in the hash table hash index 6. Okay, and then how about 55? 55 mod 7 is 1, but it is collide with 50 because 50 also in the index 1. How could you do it? How the resolution that we could do? Okay, in the algorithm, we use something like this. In linear probing, it is very simple actually. When you have the collision in the same index, okay, just put the value into the next bucket that you have, something like that. For example, 50, because 50 is populated, then I'm sorry, 85 is index 1, okay, but index 1 is 50. We can place 85 in here. So simply we take put the 85 after that, something like this. Okay, that's called the linear probing. The algorithm is very simple. Actually, you just add more number for every iteration that you have. For example, when we insert 92, okay, I'm sorry. Okay. If I think I wrong about this, sorry. Linear probing. Okay, okay, it's not. It's okay. Okay, something like this. For example, we have the next in key is 92. we use the hash function, the 92, and it will result index 1. Okay, it will collide with 50, and then we just add place 92 to the next bucket, and then it will be collide with 85. Okay, then simply we just put it in the index 3 because it's a next for 85, something like that. Okay, we put 92 in the hash function in the hash index 3, something like that. Okay, how about the next problem? For example, 73. 73 index is 3. Okay, and it collide with 92. What we could do is 73 will be put in the in hash index 4, something like that. Okay, so how about 101? It will be collision with 92. Okay, index 3, 92, and then we must put it in the index 4, but it will be collided with 73, and then we do the same algorithm, so we put it in the index of 5, something like that. So this is very simple collision resolution called a linear probing. Okay, how many hop that we the longest hop that we may be doing? For example, 92 is the first hop with colliding with 50, and then the second hop will be colliding with at 85, and then we will place it in the index 3. So the longest hop is 3, something like that. Okay, this called the linear probing. It's simply just when the index is populated with other data, we choose the next index that we that is still empty, something like that. Okay, do you understand about it? Do you have any question? Is there any question? Okay.
No. Yeah.
Okay. Yes, it's simply that when you don't have when one index is already populated with a key, you simply move to the next bucket. Okay, something like that. This is but with this algorithm, we maybe the hop is large. Okay, the hop is large. For example, 3. When we are using this linear probing, sometimes the data will be clustered. For example, this data, when we see the 92, it is index 1, 50 is index 1, 55, 85 is index 1, and 92 is index 1. Okay, so this is called a cluster. Because we will populate it to index 2 and index 3. It will become a problem when the cluster is big. For example, when we have so many hash index that resulted by index 1, it will have a cluster like this. It is not good. So the hop will be bigger and bigger. Okay, that's why we need some new algorithm. That's called the second algorithm. It's called quadratic probing. Okay, it is very similar to linear probing, but there is some different in here. For example, here 50, 776. is already here. Okay, for example, like that. Okay, and then how about 55? 55 will be collide with 1. Okay, will be collide with 50 here. So we calculate the next algorithm, something like this. Sk is hk plus 1 the power of 1, or square of 1. Okay. So when we calculate this, the fit 85 if 1, okay, plus 1, because 1 power of 1 is 1. So it will become 1 plus 2 mod t size. The t size is 6, so the index will be 2. Okay, and we place in the 2 here. Okay, something like that. And then how about we insert 92, something like this. Okay, the 92 will be collide with 50. Will be collide with 50, and then we calculate the second algorithm here. Okay, so it will result the index of 2, because this calculation, the first calculation here. Okay, and then we see that it will be collide with 55. Okay, this will be collide with here, this. So we need to calculate with the third algorithm, something like this. But instead of plus 2, it's plus 2 the power of 2. Okay. I'm sorry, the square of 2, the quadratic of 2. Okay, something like this. So it will result 1 plus 4. Okay, 1 plus 4 is 5. Mod t size is 5. So we will place the data in the index 5. Okay, something like this. So the cluster that we used before, it's only 2 cluster here, not 3 cluster, but only 2 cluster. Okay, and then the rest is maybe the same. Okay, the calculation is very simple, actually, something like this. Okay, so all the data will be populated, but in a different way that we see in the linear probing. Okay, so how many hop that we could use? It's maybe still 3 hop that we see here. Okay, it's 3 hop, because the key of 92 must will calculate to a 3 algorithm like this. Okay, this is still a 3 hops, but it is better. How? Because when we see the here, some of the data, it's need a 3 hop. For example, 92 with linear probing. Okay, it's need a 3 hop in 492, and then it need 2 hop for 101, and 2 hop for 73. When we compare it with the quadratic probing, okay, the hops is slightly better. For example, this one. Okay, the only element or the only key that has 3 hops, only 92. Okay, but in linear probing we have 92 and 101. That getting 3 hops to access the data, something like that. And 73, it's only 1 hop. In the linear probing, it's 2 hop, something like that. So quadratic probing usually is better than linear probing. Okay, because it is a random number, right? More random than the linear probing, something like that. So the quadratic probing is usually better than the linear probing. Okay. Okay. And the cluster here is only 2. When we see the linear probing, the cluster is 3. Okay, that's the difference. Do you have any question about it? You have question?
No, teacher.
Okay, maybe we will
Teacher,
next.
sorry,
Yes,
teacher.
yes.
How do we know it is linear probing or quadratic probing? How do we know it?
Oh, the hash function is the function that we define. Okay, we know already because we define it. Okay. For example, these are two methods that we use. The linear probing is actually is +1 when the data is inserted in and then in the index that already has a data. And then with the quadratic probing, we use quadratic function like this. Okay. The first iteration is 1 times 1, and the second iteration is 2 times 2, and then the third operation is 3 times 3. Okay, and then so on. So the function or the hash function is the function that we define, not the computer itself defining this, but we are defining the function. Okay.
Thank you, teacher.
Okay.
Teacher, how can we
Yes.
know 85 equal 1? I see
How
I
could
don't.
we know?
Yeah. 92
I'm
equal
sorry.
1. In 85 equal 1.
Okay.
Why?
The
Why?
active. Okay. For example, 85. Okay, 85 is equal 1. With this. Oh, sorry. Maybe I'm using this. Maybe I clear this first. Clear erase calling. Okay. For example, this 55, 85. Okay. Why is equal 1? Because of this function. Okay. The function is hk. The k is 85. Okay. 85 mod. When you using C++, the mod is something like this. Okay. And then the table size. The table size here is 7. 1, 2, 3, 4, 5, 6, 7. Okay. The table size is 7. So 85 modulo 7 is 1. Okay. How you know
Okay.
modules, right? Is
I
the
got it.
remainder of yeah.
Yeah.
Okay. And then when you knew that this 1, it is collided with 50. Okay. And then because it's collided with 50, we use the next algorithm, this algorithm, something like that. Okay. So 1 plus 1 times 1 is 1. It's equal to 2. And then it will be mod with 7. So it is 2. Okay. Something like that. So we place the key 85 into 2 here. And so on. Something like that. Okay. It's a simple mathematical operation. We are using the remainder of the division. Okay, it's called modulo. Okay. Okay. The next algorithm that we will discuss is called the double hashing. Okay. The double hashing is we use two different hashing function. Hash function that we define. Okay. The common operation that we use, the common algorithm that we use is here, the first algorithm first, and then the second function is here, second function. Okay, we have two functions. The first is maybe the same as we discussed before. The hash function of k is equal to k mod t size. Okay, and then the second function is I call it HA or G or something like that. Okay, and then it's equal to a prime number. We define a prime number that is smaller than the t size. Okay, we define a prime number that is smaller than t size minus the k. Okay, the input modulus the prime number. Okay, the prime number that we determine. Okay, define. For example, we have a t size of 7. Okay, because we have 1 and 7, and then we choose the prime number of 3 because 3 is smaller than 7. Okay, we could use other prime number, for example 5. Is it 5 prime number? Yes, 5 is prime number. And then other prime number that smaller than 7. Okay, the smaller the t size. And then the calculation is, the first calculation is still the same. We use k mod t size because we use this algorithm. Okay, HK, the first algorithm. So I think the 5776 there is no problem because we only use this algorithm, and then there is no collision in here, so it is okay. The second is 85. It will be collide with 1. Okay, it's collision with 50. So the next thing we do is calculate the hash function of 85 with this function. Okay, 85 with this function. So the function is the HK. The HK is here. It is the HK plus 1 because it's the iteration 1 times the second function, this function. Okay. HAK is equal to prime number that we define. It's smaller than t size, the table size, minus the k modulus prime number that we define. Okay, the prime number is 3 and the t size is 7. Okay, we use this simple calculation. It is actually simple when you use Microsoft Excel. It's very simple. Actually, when you make the programming in the C++, is really simple algorithm actually. But maybe when we see it's a little bit confusing, but actually it's very simple. Okay. So trust me, I already calculated. Okay, I'm using an Excel. I'm sorry. Here, I do the calculation with Excel to do that. To do this. Okay, do you see my Excel screen?
No.
No.
Okay, maybe I'm sorry. Maybe okay, this. I do the double hashing algorithm using Excel. Okay, the first iteration is very simple, something like this, because the algorithm is k mod t size. I'm just using this. Okay, the t size is 7. Okay, and then the second algorithm I use something like this. Okay, but it's follow the algorithm, this algorithm. Okay, follow this formula, and I'm using the Excel to do that. Because I'm lazy. Okay, so I do this. I don't want to calculate it by myself. Okay, I let Excel to do this. So trust me, that is the result of the calculation. Okay, just don't question me about the calculation. So when we use this function 85, the result is 1, is collision with 50, and then we will use the second function here, and then it will result 3. So we place 85 in the index 3. Okay, and then how about the next number? 92 is 1, collision with 50, and then we use the same function here. Okay, and it will result 2. It will result 2. So there is no collision anymore with 85. Okay, so we place 92 here, and then the rest is the same. Okay, for example, 72 will be collide with 85 because it is index 3, and then we use this calculation and we get the index 5. Okay, and then the 101 is the same. It's index 3 which collision with 85, and then we use this function, the second function, and then we will have 5, something like this. Okay, how many hop, maximum hop that we use? It's only 2 hop. It's much faster than 2 other algorithm. Okay, something like this. Okay, do you have any question?
No.
Okay, could you understand it, or maybe could you calculate yourself when I give you a problem? Maybe in the end of this lesson, I will give you some problem, okay, about this. Okay. Okay, it's already 1 hour in our lesson. I think we need a break. Okay, I will give you a break for 5 minutes. I will be using the meeting recording time. This is actually 1 hour. I think 1 hour 1 minute. Okay, we will meet again in 1:06. Okay, in 5 minutes from now. Okay. Okay, thank you. It is 5 minutes already. Okay, these three algorithm that's called the open addressing. Okay, because we could address our index in everywhere in the hash function in the hash table. Okay, that's called the open addressing algorithm. Okay, method. And then we next to the next algorithm that called the separate chaining. Okay. In separate chaining, we will using a linked list to do that, to save our data. Okay. The separate chaining algorithm is very simple actually. We calculate the hash function using the standard hash function like this. And then when the data is colliding, it just make a chain using a linked list to that data. For example, like this. Okay, we have the table size of 7, and then the input is the same like the other example before. Insert 50 because 50 is index 1. We insert in index 1, something like this. Okay, maybe it's a little bit different that derivation that I write before, but I think it's not a problem. 50, and then when 700, we create a linked list that the first index is 700. Okay, and then when we calculate 76, it become the index 6, and we create a new linked list in the index 6, something like this. Okay, maybe you need to know about linked list. The linked list is the data structure. Maybe you will learn about it after the pointers. Okay, and then you will know how is the data the operation in the linked list. The concept of a linked list is very simple. It's it will make a chain based on the pointers. Okay, and then maybe we try inserting the 85 key 85. Okay, 85 will be collided with 50 because the index 1 is already populated with 50. Okay, but what we will do is just make a chain after 50. So we make a chain, place 85 next to 70, 50, something like this. Okay, we make a linked list, something like this. So we make a chain like this. And then, for example, we insert a 92, the index, the same index, index 1, and collision with 50. And then usually we place it next to 50, but there is 85 there. So it will collide with 85. All we could do is just make a new list or a new change to the next of the 50 85. Okay, and then the hash index 1 will have a linked list, something like this. 50 will be addressed to 50 85 and 72. This data structures is called the linked list. Okay, you will, I think you will learn it in a short time. Okay, and how about the next 73? 73 is index 3, and we just place it in the 3. And then 101, it's index 3 with collision with 73, and then we just place it next to 73, something like this. Okay, this algorithm, that's it's called the separate chaining. Okay, when we have a same hash index from the hash function, we just place the key next to the latest element in the linked list, something like that, in the same index, hash index. So we could construct our hash table, something like this. Okay, and then when how many chain that do we have already? The longest chain is 3. It's in the index 1. Okay, so we need 3 hop to maximum 3 hop to retrieve all the data in this problem. Okay, this is called the separate chaining. Do you have any question about this?
No, teacher.
Okay. Okay. That's 2 type of how collision resolution method that we could do. The first is called the open addressing, and then the second is a separate chaining. This is the separate chaining. Okay. But for example, in the here, in here, for example, okay, we have the table size of 7. We have 7 table size. What happened when we insert a new element to the hash index? Is it possible? For example, we insert for example, we insert new data, for example, 100, something like that. Is it possible?
No.
No, teacher.
Or why not?
Because if the size reach the maximum size of the key.
Yes. Because it's the maximum size of the hash table is only 7, and we have 8 element here. So the last element cannot be inserted to the hash table. Okay. And how about in separate chaining, something like this? Okay. Maybe we have the element 100, for example. How about it? Is it possible to insert the hash table?
Yeah.
Yes, teacher.
Yes, it is possible. Okay. So the modulus of 100 is 2. Okay, because 100 is 3. I think 100 is 2. So we could create a new linked list here, and then we place it here, 100. Okay. So theoretically, when we using separate chaining, there is no limit of how many data that we could insert to the hash table. Okay, but sometimes it become a problem because the chain will be longer and longer. The more we insert the data, there is a potential that the linked list will be longer. So the hop will be longer too, something like that. Okay. So there is an advantage and disadvantage about the open addressing and separate chaining. For example, in open addressing, maybe we require more computation when there are collision in there. For example, when we are using the double hashing, we need 2 calculation there. The first hash function and the second hash function. So sometimes we need more computation for open addressing. But in separate chaining, we don't need that computation. We just place the data next to the existing data in the linked list. Okay, it's simpler to implement, and it's simpler to yes, it's much simpler. I think. Okay. The second is open addressing is the table may be full. Okay, the table may be full, something like the example before. But in the separate chaining, it will never fill up as long as you have a large memory. Okay, it will be filled up when the memory is full. The third about open addressing and separate chaining is open addressing require extra care to avoid clustering or load factor. Okay, just we saw about the linear probing first. The cluster will be sometimes when we choose the algorithm wrong, the cluster will be happening. That's why we have to choose the best algorithm that we could use in our problem, in our specific problem. Okay, but in this separate chaining, there is that problem will never be happening. Okay, because the characteristic of the linked list. Open addressing is used when the frequency, okay, it's related to number one because, sorry, not number one, but number two. Okay, it's related to number two. When we're choosing the open addressing, we must know how many table that we use, how many data that we have. When we don't know how many data that we have, it's better that you use the separate chaining because there is no limit to separate chaining, but in the open addressing, you have a limit in the table. Okay, something like that. The five consideration is open addressing provide better cache performance. Okay. Yes. In this not. Yes. Because it very we just only need an array to store our data, but in the separate chaining we use an array and then it followed by the linked list. So the index will be, the cache will be need more computation to do searching, for example. Okay, and in open addressing, the slot can be used even if it doesn't map to it. Yes, for example, in the linear probing, when we use when there are a collision, we use the next address of the memory that's called that it's not the index itself. Okay, we use the next slot of the memory of the index when there is colliding. But in separate chaining, some of the data, some of the slot, we don't use some of the slot. For example, this example, right? This example, slot 4 and 5 is unused. We don't use it. It's a waste, something like that. Okay. And then, yes, because the open addressing only using an array, so there is no link, or there is no link for one data to another data. But in separate chaining, we use extra space for a link. When you learn about the linked list, maybe next week or I don't know, you will know that when we are using a pointers, we need some space, some extra space to store the pointers or the address of the next element. That's why in separate chaining we use we need extra space for links. Okay, something like that. Do you have any question? Okay, maybe we will next to the next slide. Okay, what we discussed before is the key that usually using an integer. Okay, but sometimes our data, the key of our data is sometimes it's not an integer, maybe a string, maybe it's something, maybe yes, maybe character or something like that. Okay, so how to determine the key to the hash? That's the problem that we have. We usually using the key as a parameter to the hash function, but sometimes the key itself is not very unique. That's why we need to make some operation to make the key as unique as possible, something like that. Okay, so there is some method that we could use. The first method is called the folding, and then the extraction, and then radix transformation, and the string based key hashing. How we make a key based on string. Okay, for example, the folding. The folding is the concept that the key is divided into several parts, and then the part will be folded or be combined one another. For example, we have a social security number. For example, here, maybe you have identity number, something like that. There is so many character in the security number, okay, or the identity number. Sometimes the identity number has a string like this, okay, like this and this. Sometimes it's not, but sometimes the number is so large, very large, that some maybe there is a potential of collision. That's why we need to divide with the folding method. We divide the number into several parts. For example, 3 parts. We separate the number 1, 2, 3, 4, 5, 6, and 7, 8, 9, and then this number will be added. Okay, will be added, and then the result is 1368. Okay, so the hash function maybe become like this. Okay, the hash function of 1, 2, 3 dash 4, 6, 5, 4, 5, 6 dash 7, 8, 9 will become 1368 mod the t size. Okay, the t size is the constant that we have to define before. Okay, or maybe we could divide it into 5 parts. For something this 12, 34, 56, 78, and 9, and it will result in the smaller number 189, for example. And then we use the 189 and use the mod operation based on the t size. Okay, something like that. That's called folding, based on the dividing the data. And then maybe some algorithm using something like this. Okay, the same social security number, something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. It could be divided into 3, but the second part of is reverse, something like this. Okay, the original number is 486, 456, but it is reversed into 654, and then it will be result 1566 when we added this together. It's not the same with the original number like this. Okay, something like that. Sometimes the algorithm doing something like that, so this is the result of the algorithm. Okay, or maybe we use the security number or some number using a string, for example A, B, C, D, something like this. We could convert the character every character of the input, and then we use the XOR operation in C++. For example, in C++ we have XOR operation. Then, for example, this we divide it into 4 parts: A, XOR by B, XOR by C, and XOR by D. It will result the 4, and then it will be use the mod operation based on t size. Okay, or maybe we just divide it into 2 parts. You see it? AB will be XORed by CD and will result 518. Okay, so maybe we could use something like this when we have a string-based input. Okay, that's called folding. So the folding is the main idea is the key is divided into several parts, and this part will be combined together. So we will create a new number based on the folding methods. Okay. Do you have an equation? As I can say before, the key usually is integer, but sometimes it's not. So we have to do something about it, something like that. Okay. The next is extraction. We extract the information from the key that we have. For example, this. We have a student ID. For example, this is the student ID of my department. Okay. 201510123, something like that. But the first 6 digit, it is maybe a department identity number. So every student will have this number. Okay, we'll have this number. So we don't need that. We just omit this data, delete this data, and then we just using this as a input, something like this. Okay, so the hash function of this number usually when you have a student number, it is actually not a number. Okay, usually it is a string, but we divide into that and we omit the number that have the same for every student, and then we just need several number the rest of the number. Okay.
I think we could not hear you well, Mr. Yudihi. Could you check your microphone? Looking for.
Oh, okay. I'm sorry. I'm happen to mute the microphone. I'm sorry. Okay. Yes. In extraction method, maybe we could use something like this. For example, this is the same number that we discussed before in the folding. But what we do is extract the first 3 number of the identity number, for example, and then the last 3 number of the identity number. This number will not be used. Okay, we only extract this and this. and then we use the plus operation or the add operation. So we will have this result. Okay, this will be used as the key, something like that. That one example of the extraction method. Okay. The goal of extraction method is to make the computation easier. Is the make the calculation. Yes, the calculation is easier. Okay, so we have to omit or delete some of the data, and we only use data that matters. Something like that. Okay. Do you have any question for this? Okay. The next is a radix transformation. It is radix, right? It's a concept to converting a number into another number base. Okay. For example, we have a number base of 10. Okay. 45 is a decimal number. Okay. This number is transformed into a normal number. Normal number is base 9. Okay, base 9 number. So from decimal, we transform the number using the base 9. So we could have 4, 2, 3. But this 4 to 3 is a normal number, but treated as a decimal. So the hash function of 345 will be converted into this. Okay. We use radix transformation to make a new number, but that new number will be what I call it transform it into a new number base, but treat as a decimal. Okay. This is happening because sometimes we have data like this, okay, 10, for example, and then 20 and 30, something like this, for example. When we use the mod, for example, modding, we use the mod, it will result in 0. For example, it's the table size is 10, okay? For example, the table size is 10. It will be result a 0, something like this, for example. Okay, maybe we have a data something like this. The key always always like this, for example. So we need to transform this data into the nonal system or the other base system. For example, we transform 10 into a nonal system. So I think it is 11, something like that. This is nonal is 2, okay, and then 1, 2, okay, 22, I think. Okay. 18, okay, yes, I think it's correct. And then it's a 3 and become a 10, 33. Okay. When we mod it into 10 with a base 10, it will be 1, and then it will be 2, and then it will be 3, something like that. So instead of we are using the decimal number, we transform the number, but it's treated as a decimal number. So we could use operation like this. So the index will be always different, something like that. Okay, that's called the radix transformation method to avoid the collision. Okay. Do you have any question? Okay. Maybe the last part of this lesson is about the string-based key hashing. Many of our data is the key is based on string. Usually we use an integer as an index, but sometimes we don't do that. For example, the student number. Actually, student number is not a number, but a string with the number character, something like that. Okay. But sometimes we have to transform the string into an integer, so we could feed it to the hash function. Okay. Suppose we have the data, okay, a string, and then we convert the every character into a number, something like this. When we have an A, it will be transformed into 1, and when B will be transferred to 2, C will be transferred to 3, and so on. Okay. Then we have a hash function like this. Okay, HABC. A is converted to 1, B converted to 2, and 3 converted to 3, for example, and then will be modded to the table size. But maybe we have a different string, for example, CBA. The C will be transformed into 3, and B into 2, and A into 1. But when we added this together, it will become 6, and then it will and when the second function, it will become 6 too. This will be collide. Okay, the string is different. You see, the string is different, but the transformation is the same. It will be collide. That's why when we have a string-based key, a string-based key, we cannot convert it this way. Okay, because it is very possible that will be collided. That's why we need some algorithm that call the method that call polynomial rolling hash function to minimize this effect. So the simple thing that we could do is something like that. We extract all the data character by character, and then every character will be multiplied by a p. P is a prime number. Okay, a prime number. And then the second character will be the p, the power of 1, and then the third character will be multiplied by p, the power of 2, and so on, something like that. And how we determine the p? How we determine the p? We could choose any prime number. Okay, any prime number, but the best case scenario as maybe we could choose P31 and P51, for example. Why P31? When our data is only a lowercase. Lowercase, I think the lowercase, we have how many characters in our character? A, B, C, D, E.
26.
Yes, 26. We have a 26 character in character. The closest character to the closest prime number to 26 is 31. So we could use 31 as the P. Okay. But when we are using lowercase and uppercase, it will be 52. Okay. Maybe we could use the prime number of 51 because it's the closest. Okay. This will be good enough for using this polynomial rolling hash function. Okay. Maybe we have a character more than 26. For example, there is a symbol or something like that. So we could choose the closest prime number that closest to the number of character that we use. For example, we have we only use 5 characters So we could use the prime number of 5, something like that. Okay, we choose the closest prime number. Okay, so with this example, we could use something like this. So for example, the word is hello. The hello, the h will be converted to 8, and then because it is all is a lowercase, we assume that all is a lowercase. Okay, so 8 the power of 31 sorry 8 multiplied by 31 power of 0, and then so on and so on, something like that. And then it will always be modded by the table size, something like that. Okay, you could calculate this by yourself. Okay, so this is one method to use the polynomial rolling hash function, okay, to string based key hashing. Okay, do you have any question? Yes, usually in my department we have two meeting for hashing theory. So the first meeting is about this, and the second meeting we will try many user-defined function. Is it better or not? Something like that. Because when we talk about the hash function, is very depend on the problem. Okay, there is no best hash function. We have to try to get the best hash function for our problem, something like that. So many things that we have to do, something like extraction, folding, and something like that. So we need to experiment, have a many experiment to get the best hash function for our needs, something like that. Maybe some of the key, the hash function is very simple. For example, we just need the last character of some number, something like that, as a hash function itself. Okay, this is very possible, something like to do something like that. So there is no best hash function that we could use for every problem that we face. Okay. Okay. Do you have any question about it? Okay. Maybe some of you question how to determine the t size, the table size. Do you know how to determine the table size? For this example, yes. For our example here, too much. Okay, we use a table size of 7. Okay, how is that? Because we only use 7 data input in here as an example. Okay, but the question is how we determine the t size. How many t size that we use? Do you have an answer about of that? Do you have an opinion? How we determine the t size? For example, we have data about 100. Okay, how many t size that we use? We will use Yes, the best practice is we use the closest prime number of 100, greater than 100. Okay, we use a prime number greater than 100. It will become the T size, something like that. Okay, why we use the prime number? It's maybe a interesting discussion about the why we're using the prime number. I searched it in the internet and in the books. There is no answer about that. There is no certain answer about why we are using the prime number. But I think we are using the prime number because the collation of when we are using the prime number, it could be minimize the collision. That's why we use the closest prime number, the greater closest prime number of how many data that we have. Okay, so for example, we have a data of 127. Okay, we need a greater a prime number of 127, or maybe 50. We need a table size also greater than than this. Okay, sorry, something like this. For the T size. Okay, but when you don't know how many data that you have, you could choose any prime number that large enough based on your estimation. Okay, but don't use the open addressing, but you must use separate chaining. Okay, for example, you don't know how many table that how many data that I have. Maybe you could just choosing prime number 31, something like that. Okay, and then you use separate chaining to implement your hash table, something like that. I think the Java programming using 31 to do the hash function that they have. Okay, the Java. And I'm not sure about the C++. Okay. Okay. I think that's all that we have to discuss. And what we have learned for this, the first is the understanding about the hashing, the hash function, and the hash table. Okay. The hash function is the function to convert a large number into the smaller number, or the large number into an index for the hash table. And the hash table is the bucket of the data that we want to insert. Okay. We learn about the hash collision. Why it is happening, and then what is the real solution that we could do. Two method that we learn here about is open addressing and the separate chaining. Okay, the open addressing is usually is very efficient and very fast, but separate chaining is more flexible because we don't need to know how many data that we have in the for the hash table. Okay. In open addressing, we learn about linear probing, and then quadratic probing, and double hashing. There is so many algorithms that we don't discuss here because the time is very limited. And then the advantage and the disadvantage about open addressing and separate chaining. Okay, and then we talk about how to determine the key to be used in the hash function, because sometimes we have the key that have some characteristic. Sometimes the key is when we use the key as the parameter of the hash function, there is a possibility of colliding. So we have to process the key to be used as a parameter in the hash function. Okay, that's what we learned so far. Okay, I think I hope you try to program in C++, for example. I think it's so many tutorial about it in the internet. You could implement that by yourself. Okay, and then maybe if you want to practice, I give you one practice. Okay, using linear probing. Insert the key in this number. Okay, 32, 53, 22, and so on, with the size of 10. Maybe you could change the t size. For example, you are using 10, and then you are using 11 or something like that to practice. Okay, usually we are hard. I have a hard time to determine the insert key, for example. Okay, so maybe you could use this, and then you just change the t size for practice. And then maybe you using the quadratic probing or something like that, and then you could change the t size by yourself. Okay, for practice. This material I will send it to Mr. Chana for the material. The material last week I will and this week I will give to Mr. Chana. Okay, and you could learn from that. The video too. Okay, the recording. Okay, I think that's all for this week. Maybe do you have any question before we do you have any question?
Teacher, could you share your slide in this team?
I'm sorry. Upload the data. I think I don't have any. Yes, I couldn't do that because I don't have any control for chatting. It's limited control in me, so I couldn't give you the material in the chat. Sorry.
I think it's because you're using the Gede account, and with Gede account you have an active account, and it is not possible to handle some settings like. So I think it's okay. You can pass it to me. Maybe we can connect with WhatsApp, and then I will pass to everyone in the group. It's okay.
Okay, thank you very much, Ms. Tana. Okay, I think when we don't have any other question, we could end this meeting today. Thank you very much, everyone.
Thank you, teacher.
Thank you, teacher.
Thank you,
Thank you, teacher.
Thank you, teacher.